Hello everyone, this is 7th November 2021. I am doing a project for Wawasan MBA MPM program for advanced manufacturing, and today I will be creating a simulation model for height adjustable electric desk assembly process. This process will have 5 entities, 5 processes, and 3 decide modules. So I get started so that I can get on time, otherwise it takes a long time. So let me put the create modules first. So I'm going to place 5 create modules. 1, 2, 3, 4, and here's 5. And then I have 5 processes for these 5 create modules, separate processes. So I'm going to bring them right away so that I'm preparing for the next steps. We don't need the connector at this time, so delete it. Get the processes 2, 3, 4, and 5. And we don't need the connectors at this time. We will align them later. Okay, all right. So we got the 5 processes for 5 entities all set. In between the create module and the processes, I'm going to put assign module to define the characteristics of the attributes of the create module. So there are 5 of them. So 2, 3, 4, 5, and here we go. And then let's take the connectors out. And once we have them ready, then we're going to be putting a couple of things. These 3 processes, the 5 processes, the 5 entities that we see here, 1, 2, 3, 4, 5, they go through the assign module. Basically, assign module characterizes the attribute, then goes through their individual processes, and then comes to a final production line where all 5 of them gets together and converges and converts into one entity, one product, final assembly product. So before we do that, what we will do is I'm going to add basically a record module. I'll put a record module near this first entity because this one is a pretty critical one, and that one we don't need that. And after that, I'm going to also use hold modules so that each of the 5 products that will go through the processes, 5 processes, they come to the hold modules, and individual hold modules will monitor the flow of how many can go out at the same time so that it doesn't jam up the next final assembly process. So I'm going to add hold modules here. Hold modules are available in the decision segment, and so we're going to put one hold here, and that's for the first entity, and the hold number 2 will be right here. Then there will be a hold number 3 right here, then there is a hold number 4 right here, and then finally the hold number 5. So basically, okay, we're going to take them out. All right, so we got entities, assign modules, processes, one record for the first entity. Then there are whole modules because we're moving in that direction on the right side where we will be converging into one together, a total process. Then when these processes all converge here, I want them to be match. I want to match them. So in order to match them, I'm going to bring a match module, and the match module is available under grouping. So we go to grouping, and I'm going to bring a match module. This is the match module. So the match module comes here, where the grouping is right here. And once the matching is done, the match module, I would like to take it from match module to the batch module, which means that once all these 5 entities converge into the match module to get matched up, so based on the type of products they are, I want to convert everything into a batch module. So after the match, we go to the batch module, and the batch module basically takes all these 5 entities, puts them in one batch, and takes them back to the final assembly. So before we go any further, let me do the activities one by one. So first thing we're going to do is we're going to look at the create. We're going to create them. So first thing we're going to do is in the create module, the first name I have of my product component that's coming in, they supply these 5 entities. The first entity is called the lifting column. So it's basically create one is lifting column. Remember, I am making a electric height adjustable frame that is for the electric height adjustable desk frame. So in that desk frame, the columns are very important. So it's lifting column arrival. So that's number one. Entity type is called, basically I'm going to name it column. These are made of steel, so steel column. And the type of distribution is going to be random exponential distribution. The value is 10. That means in minutes. So basically every 10 minutes we have entities per arrival will be 3, and maximum entity arrival will be 6. So with that, I'm going to click OK. So we created the first entity. Second entity is motor. The electric desk has to go up and down. To do that, we need motor. So in order to have that, we're going to put the second entity as motor arrival. Motor arrival. So that's electric motor, and its arrival. And the entity we name will be motor. So that's the entity we're going to put. Sorry, I didn't finish it yet. And then random exponential will be the will the system, and then statistics distribution, and then 10 minutes value is 10, unit is minutes, and then basically we're going to be having the same entities per arrival. That will be 3 minimum for 3 entities per arrival minimum, and maximum will be 6. So that's how it is going to be. But before that, I also want to go to the entity, the first entity, and I go to the data definition. The data definition here, and I click on entity, and I see there is nothing here. So first one is the data. Under the data definition, I go here, and I double click this, and what I do is I create the information because I want to identify this first entity with some kind of color picture. So the first entity I have here is called column, and for the column, the picture I select or identification that I select will be a what I would like to do is I select a picture that is identical to, unique to this. So we can do something like picture. Let me see what I can select. I picture box. All right, and then second one we did was motor, and we pick the motor, and then the picture we assign this with is yellow ball. So let's see if yellow ball, right there, yellow ball. Then what we do is before we move any further, I want to save this. So save the file, save as, and I'm going to go to desktop, Wawasan, 7th semester, that's my semester, CA2, upload folders, and under the upload folders, I want to do, let me see here, delete, okay, so upload folder CA2, okay, that one is um, uh, initial simulation. Okay, so that means this is the first cat we're going to do. So save, done. All right, we did the two entities, and then the third entity we do is going to be controller. So there is an electrical brain behind the desk operation. So we do controller arrival. So this is the third one, controller arrival. Entity type is called controller, and then distribution will be random exponential, and it'll be 10 minutes. Every 10 minutes, we get 3 minimum arrival and then 6 maximum arrival. So that's that. And we go to the entity again and we hit double click here. And then what we do is we add controller. For the controller, then we're going to use another color, which will be, let's see what we can pick here. So we can do, let's see, green. What else we have? Picture red ball. All right, so we got picture red ball for that. Now we go and save this. So once we save it, we go to the next one. Next one we create. So after that, we get the next one, and this is called ISP sensor. ISP sensor is intelligent protection system that goes into an electric desk, height adjustable desk. That's where you will see many times I have written HAD. That means height adjustable desk. So this one is ISP sensor arrival, intelligent system protection sensor arrival. So these are all the components. Entity is ISP. Entity is basically, we can say ISP or sensor, doesn't matter, but we put ISP. Random exponential distribution 10, and when we get it, we get 3 minimum and 6 maximum. When we hit OK, let's go to the entity below and make sure we assign a color to this whole thing. So now we are talking about ISP, and for ISP, let's choose another color here. That should be, let's see what we have left here. We have taken yellow already, red, let's see, we take the green ball. So we take green ball. Okay, we save, then we go to the last one, which is the last one is nothing but the program switch. So it's basically, we're going to talk about create program switch. Entity will be switch. Entity switch random exponential will be 10, and then it's minutes, and there will be 3 units coming in minimum, and then 6 units maximum. Okay, there we go. But let's double check that we got all of this correct. So that one is 10 minutes, 3 and 6, good. Second one is 10 minutes, 3 and 6, good. Motor arrival. Third one is controller arrival. Random 10 minutes, 6, 3 and 6. And then that one is ISP sensor arrival. Random exponential 10, 3 and 6. This one we forgot to change to minutes. So that goes into minutes. And then the last one is same program switch, random exponential, we're fine. All right, the next thing we're going to do is we're going to put assign module. So the assign module basically is very straightforward. We're going to assign the module, and this assign module will do the attribute identification or characterization for the for the entity. All right, let's look at this assign. So this assign we're going to name as lifting column arrival. So here we say assign one. Assign one is lifting column arrival. All right, this is assign one, lifting column arrival. And in this, basically what we're going to do, we're going to do entity, double click here, we're going to do attribute, and then you're going to say entity type, and we say new value 1, means that's the assignment of this value, is we're going to say 1. All right. So that one is entity type, and we got it clicked. Number two is assign module 2 is motor arrival, and basically we're going to do sorry, I did a mistake here. On the first one, it's we're going to assign here with an attribute and the entity type, and however the name will be stamp, it'll be stamp column, it'll be stamp lifting column. Basically we're going to assign a stamp, not assign, we're going to stamp it. We're going to stamp it, we're going to say stamp lifting column. So basically we're stamping it to identify it and saying it's a lifting column, and the rest will remain same, attribute, entity type. Number 1, that's good. Number 2, same thing. So this one is, we're going to say stamp motor, because this is the electric motor, and the assignment will be attribute, and then this will be entity type, and this will be number 2. So this is the entity type is number 2. So hit OK, go to number 3. It's a laborious work, takes time, sorry about that, but this is how it is. Number 3 is controller, so we stamp the controller and do the same thing, just repeat it. Attribute, entity type, and this is number 3. All right, and then we go to the number 4. Number 4 is ISP sensor, so we do stamping of stamp ISP sensor. Okay, and then here we do the same thing, attribute, entity type, and then number 4. So that's number 4, and then the last one is stamp switch. Stamp, we basically stamp the program switch. Program ITCH, program switch, and then we go into the attribute, variable entity type, and then this one is number 5. So we got it, and then here we go. So before we go anywhere, we do the savings. All right, so we connected, we basically entered information for the entities, the assigned modules, and now we go to the process. So the process, basically, we're going to start with the column assembly. So first process is actually, it's going to be the height adjustable desk, basically we call it HAD, column assembly. So this column, that is lifting column arrival, that is coming, this one is going to be the so it'll be the height adjustable desk column assembly. In short, we write it like that. And what we do is the type will be standard. As for the logic, we're going to pick cease delay release for the entities coming and they seize the resources, and then after they get value-added process, which is delay, they get released. So the priority will be medium, and then let's pick the resources. So let's add the resources. So resource number one is basically what we're going to do. We're going to do operator one. So operator one, so that's resource number one. We say okay, and then go and add another one because we're going to add a assembly jig. So it will be head column assembly jig. So right now we're going to do the second one will be head column assembly jig. Okay, and this jig is basically jig number one. So and the unit to cease release is one. So we say head column assembly jig. Okay, and then we say this one looks good. And then we have a delay type. Delay we select triangular, so that we have minimum. Minimum is 3. Basically, the value in the units is minutes. So minimum is 3 minutes. Average is 4 minutes, and maximum we have here is 5 minutes. So this way that this complete process is prepared here for the process. So we do okay, then this one is ready, and if you can see on the top there is a line here. This is the line for the queue. When the parts come in, this will be the queuing line. All right, process number 2. This is for the motor assembly. This process is the motor assembly process. So we're going to do the same thing. We're going to go and write it here, motor assembly standard. In the logic, we're going to do cease delay release, and here under the cease delay release we have medium priority, and resources we add resource number. Okay, so before it was operator 1, so we're going to do operator 2. So we have second operator here, so operator number 2. So every operator is unique. Then we go to the motor assembly jig. So we add what we add here is called motor assembly jig, and that is it. So we said okay. There is only one assembly jig here, motor assembly jig. Then we go to the delay type triangle, and on the triangular the delay type we have 1, 2, and 3. So minimum is 1, average is 2, and then maximum is 3, and hours or minutes, it's in all minutes. There we go. Then we go to the number 3. Then this is the controller assembly. So number 3 is controller assembly. Controller assembly. In controller assembly basically has medium priority, and it has got resource number operator number 3. So this one we do cease delay release, and under cease delay release we're going to add resources. In resources we're going to pick operator number, so we're going to put operator number 3. We say okay, and then we have controller assembly jig. We add another one, and we say controller. So let's see. So you have got controller assembly jig, and controller assembly jig, and that is controller assembly jig. Good. All right, and then we said okay, and then in the delay type I have pretty much like 1, 2, and 3 minutes. So 1 minute minimum, 2 minutes average, and 3 minutes maximum. All right, so that's that. We said okay, that one is done. Better save it. Okay, one click, done. Process number 4. Process number 4 is the sensor assembly. So it's basically process number 4 is the ISP sensor assembly. So it's the ISP sensor assembly. In standard logic is cease delay release, and let's add resources, and the resources here is operator number 4. So we pick an operator and we change the number to number 4. We hit OK, and then add one more for the ISP sensor assembly jig. Here we type ISP sensor assembly jig. All right, so we got it. And then we hit OK. Once we do that, we go to the delay type triangular. Again, we select the triangular. Minimum is 1, maximum is 2, and sorry, average is 2, and maximum is 3. Hit enter. That's done. The last one is the program switch assembly. So again, if you look at it, this is the program switch, and the last one we have here is program switch assembly. So we're going to type it in as program switch assembly standard. And then in this one, in the delay action logic, we do the cease delay. And then in the resources, we're going to add resource will be operator number 5, because we have already used 4 operators before. So we're going to put 4 and then add it, change it to 5. That's done. And then program switch assembly jig, we're going to use a jig here. So this will be the program switch assembly jig, and this is 1 unit. So there we go. There it's go. So we have got 1 operator and 1 assembly jig, and then delay type is triangular. And in this triangular, we have minimum 1 minute. Sorry, I need to make sure that I change it to minutes. Maximum average is 2 minutes, and maximum is 3 minutes. And then we hit enter. Just to double check, make sure we did everything correct here. Minutes done. Very good. This one, minutes done. 1, 2, 3. Let's double check this. This one I forgot to put the hours to minutes, so there we go. And then we have this one also needs to be changing from the hours to minutes. And the third one is program switch. Everything looks good. Ready. Okay, the next one is record. We're going to add a record module. Record module for the column, because column is basically the main component of this electric height adjustable desk, because without the columns you cannot lift it up and down. So we're going to put a record here to see how many columns are passing by. So record column arrival time. So what are we going to do? We're going to put record. We're going to say column arrival time, because this is all about columns. And then here we're going to go interval time. So let's see what we can do here. We're going to go here. We're going to put time interval under the type. We're going to do time interval under the statistics. Then we do attribute. We're going to do column arrival time. So the name here is column arrival time. All right, and then the last one, the tally name. The tally name will be tally column arrival. So we're going to do tally 1, which will be column arrival time. So it'll be column arrival time. All right, so that's column arrival time. And then after that we do OK, and then OK here. The record is done. Once the record is done, then we are going to go into the hold module, because all of this together, remember, are going to come in to this match batch and then go into a final assembly called the final assembly, which is not here yet, but we're going to put it in. But before that, I want to put the hold module so that each area, when these entities are coming out from these individual processes, they are held for a certain number of quantity to be released at a given time. Otherwise, they will, really jam the next process. So let's go to hold. So hold, we're going to, what are we holding here? Hold 1 is holding the column. So hold 1 is basically we can say column. hold column, wait for signal. Instead of that, we're going to do scan for condition. We're going to put an expression here. This expression will be under the queue, and in the queue we're going to say current number in the queue, which says number queue batch 1 queue. And basically we're going to go here and we're going to pick match 1 q1. So match 1 q1 means we're going to match this queue will be held here because of the q1, match 1 q1. And in the match 1 q1 we're going to be doing a number here that will say basically we need to do match, not match 1 q1, but we're going to do, let me see, what we're going to do is match all q, match all q. Where is the hold 1 q, match 1 q, right? So we're going to put match 1 q1, that one, okay. And then we're going to put a number here that will be less than 10, which means that anything that comes in, again we're going to check anything that comes in here, anything that comes in here, sorry, did a mistake here. Anything that's in this queue less than 10 will be allowed to go, but as soon as it hits 10 or more, they will be held until they clean up slowly. So that's match 1 q1, okay. And then here we have hold column. Basically it says hold column or q, hold column q, and this one is q here, q type. And here it says match 1 q1 less than 10 means we allow less than 10. Below, above that, then we hold it. Then we hit enter, go to number 2. Number 2, we do the same thing. We're going to say hold, what is it now here? Motor. Motor is arrival. So we're going to hold motor. We're going to hold motor, and we're going to do here scan for condition. And as you can already see, we have queue and hold motor queue, which is fine. We're going to right click here, go build expression, and in here we're going to go queue, and in queue we do current number in queue, and under current number in queue we're going to pitch match match, let's see, either that or match 1 q2, match 1 q2. So here is q2 is coming, we are matching q2, and then we're going to hold. Another thing is we can do, we're going to add the number 10. So we got the number 10 here, less than number 10. That means anything above 10 or beyond 9 will be held up here. So that's done. Next one. This one is hold. 3 is hold controller. I'm going to keep quite a little bit and see if we can move it faster. All right, so we go to queue and then current number, and then we say match. So batch 1 queue, hold queue, hold 5 q5. Okay, let me just do one thing here. Okay, so skip some, try to cut down on the time. So this one, the last one is hold 5, which is the program switch. Hold program switch, and we're going to go again for the same thing, scan for condition, and then we're going to do build expression, go to queue, and under the queue we're going to do current number in queue, and here we're going to do match match 5. So basically we're going to do match all q5, and then here we're going to do less than 10. Okay, hold program switch, and it looks good. Okay, so the hold modules are all done. Now we're going to do the match module, and then we're going to move forward so that we can continue with the connections and take care of it. All right, in the match module, basically what we're trying to do is we're going to match everything that's coming in. So we're going to do not match one, but we're going to do match all. So we're going to, let's see if there is a match all here. If not, we're going to do the match all. Let's say we're going to write here match all. Number to match, we're talking about 5 because we have 5 entities coming in, and it'll be the any entities, and then it'll say no batch because we're not talking about batch, we're talking about any entities that come will match all here. And so with that we do this, and then you got 5 queues here, as you can see. Before we go into the batch process, what we're going to do, we're going to do the save, and once we are saved, we're going to connect. So let's connect that one to this one, and this one, we connect that one to that one, then here to the record, and then from record to hold, and then we take from the hold, we connect to the first point at the match. All right, then we do the same thing. All right, so we're going to do it now one more time. Let's see. Why did it not do it properly? So, all right. Okay, to connect all of them, 1, 2, 4, 6. All right, now we have connected all of this until the batch module, and then we are all connected, all the entities, the assign modules, the processes, and then the hold module. They have all gone into the match module. In the match module, they get matched, and from there we converge into the batch. The function of the batch is to basically take all these different entities coming in, group them together into one batch, and send it out. So we're going to go and do quickly the batch module, and the batch module basically is talking about batch together. So we're going to do batch together permanently. So basically we're going to do batch together, and it will be permanently. Okay, batch together permanently, and the type is permanent, and then batch size is 1 because we want all of this to converge into one batch. Each time the batch will send out to the next process, the final assembly, it'll be one batch that's going out at the same time. Here we'll take last, and any entity we're going to put rule. We're going to do by attribute, and then here under the attribute we're going to do, let's see if we can have any entity, so it'll be entity type. And then representative entity type will be column. So we're going to say hit yes. So that's what it is. And then now we're going to connect all these items from there to the single entry point here. So all of this output from the match will go to the batch. Here we go. Okay, so this is now pretty much done here at this time. Okay, now the next step in this whole process is going to be, we're going to go and add the final assembly process where all of them will get into the assembly. So to do that, we're going to bring, again, we go to the basic process. Under the basic process, we basically, we're going to bring in process here. And this process here is called the final head assembly height adjustable desk assembly. So that one is coming here. And then right after the assembly is final assembly is done, we're going to be doing a assembly inspection. So I put the assembly inspection line here. This will be the assembly inspection. Actually, we don't need to have the connection right now. And then right after the assembly inspection, we're going to do a decide module. The decide module will basically decide what is the outcome of the inspection. And then after the inspection decision, we're going to have a rework. So basically the rework will be another process. So that's coming here for rework. And once the rework is done, then we put another decide module that will decide whether it's going to get scrapped, reworked, accepted, rejected, whatever. And then it'll go to the dispose module. So we're going to have the 3 dispose module right here, 1 and 2, and the last one will be 3 right here. I'm trying to make it faster as possible because these things take a lot of time. Unfortunately, cannot skip anything. You have to do one by one. Okay, well, let's start with the head assembly, the final assembly process. So the final assembly process, we're going to name it as final HAD, that means height adjustable desk assembly, final height adjustable desk assembly, which will be basically standard. And then we're going to do a logic of basically seize, delay, release. And in this, we're going to have one operator. Actually, we're going to have two operators and 2 jigs. So previously we have added operator, and then last operator we added was number 5. So we're going to go and make it number 6. So there we go, number 6. So and then we're going to add one more operator here, which will be the operator number 7. So we're going to do 6 and 7 here. So we added 2 operators. Okay. Then we have to add 2 jigs, final assembly jigs. So we're going to add. So we're going to do final head assembly, HAD assembly, and we're going to put it as jig 1. Final head assembly jig 1. Okay. And then we add one more jig, which is the basically we can pick up the final head assembly jig 1 and make it number 2. So we've got 2 jigs and 2 operators right here. With that, we go to the delay type is triangle, and we're going to do inspection for 1 minute, and the average value is 2 minutes, and then the maximum is 3 minutes. Let's not forget to change the hours to minutes, and we hit OK. All right, so that's what the head assembly is doing. So what we are doing now is we're going to connect. From here, we're going to take it to head assembly. So the batch goes from here and connects to the head assembly. This is the final assembly. From here, basically the next step is the assembly inspection. So assembly inspection is this one. So here we're going to change the name to assembly inspection. Assembly inspection. The process is standard, and then this logic is going to be cease delay release, and the only difference will be in the resources. on the cease delay release, in the resources we have quite a few of them. So number one, we're going to add operator number 8, because remember the last operator was number 7. So we got 7, we go there and we do make it number 8. So we have operator number 8, 9, and 10. So we have 3 operators here. Add one more operator, which will be operator 9. Then we say OK, and then add one more operator. We pick the last one, operator number 9, make it number 10. So that is operator. We got 3 operators, and let's now put final assembly inspection jig. So we're going to do final assembly inspection. Basically, write the whole thing down. Inspection jig, and jig will be 1. And final inspection assembly jig 1. Then we have final inspection assembly jig 2 and 3. So we need to add final assembly inspection. Let's pick up from the assembly inspection jig and make it number 2, and then go and pick up the third one, which will be the final assembly inspection number 3. So make it 3, and we said OK. Triangular is basically our delay type, and with this we have we convert this into minutes, and from minutes we have basically this is not triangle type. This is, we take the uniform type. Here the inspection will be done uniformly, and the uniformly it will be done basically in 1 minute, or it will be done in 2 minutes. So basically that's why we have uniform selection on the delay type. Okay, we hit enter. Okay, and then so assembly inspection is done. We connect the final assembly into assembly inspection. Now once the inspection is done, there has to be some kind of decision, and the decision is basically whether the product is going out, or is it going to be passing or failing or whatever. So we're going to do the decision. It's called the final assembly quality. So here it is, the final assembly quality. All right, so that's it. And then we're going to select n by chance. We're going to select n by chance, and in here we're going to go basically, let's see what we have selected is going to say that 90%. That means 90% of the time final assembly quality. Basically we are saying 90%, sorry, okay, so trying to enlarge the font a little bit. Okay, so first assembly quality, final assembly quality. In this one I would say 90%, which means I will say it here, 90% pass. So if you see here, it says 90% pass. That means anything that's 90% or pass will go from here directly to some dispose module. And if it is not 90%, then it'll come back to the other module. And this module is nothing but the rework module. So basically we're going to add a rework module right here, which is the module called rework. So here's the rework module, and in the rework module basically again we have standard, and logic is cease delay release, and in cease delay release we're going to add one operator, which is operator number, because we already had 10 before, so we're going to go operator number 11. So this is the operator number 11, resources, and this is for rework. And the delay type is going to be triangular, and it's going to be minimum of 5, and then or average 6 minutes, and maximum of 7 minutes, and the time requirement unit is minutes. Okay, so that's rework. So now what happens is we connect this one. From here we go to rework. Basically 90%, this one it says 90% final assembly quality, 90% pass. That means 90% of it time it will pass. If it is not 90%, then it goes to rework. Once it's rework, it goes through a decision process because it needs to figure out whether it's acceptable or how much is the rework. Even rework could have rework and failures or acceptable limits from here. So here we put a decide module that says past. We can say past rework. Okay, that means past rework. Okay, and then if it is past rework, what we do is we do two-way by chance, and we select two-way by chance, and we select 95%. All right, 95% as passing rate here. So we're going to do past rework, and we're going to say basically I'm trying to make the font bigger so it can be visible. So that's false, and here it says true, and basically this is past rework, and I'm going to put here 95%. And if you look at it, it says past rework 95% true, means it goes in the dispose module. False, it also goes to another dispose module. So basically we have now, I'm going to show you what we are talking about dispose module. The three dispose module that we are talking about, the first one is actually product shipped. So what are we shipping? We are shipping head assembly shipped. So basically here we're going to basically say height adjustable desk assembly shipped. So that's our first dispose module. Second dispose module is nothing but rework and salvaged. Rework and either we say shipped or we say salvaged, it doesn't matter. And so I'm going to put reworked and salvaged. And salvaged means it goes to the next process or it can get shipped out, either way. So that's the next one. The third one is nothing but, guess what? It's going to be scrap. Why? Because either we ship, either we rework, or we scrap it. So here, if you look at this, the true, if it passes, goes to the salvaged and rework. If it is false, means if it doesn't pass the 95%, 5% fails, goes to scrap. But before that, we're going to use record. We're going to use record module in all of this. So before that, we will connect a record module in between so that we can have the record of what is going out in the each of these items that are coming out of the final inspection and shipping out. What are the final numbers? So the record modules are going to be for all these three. And so what I'm going to do, that I'm going to show you how do we do this, but before we do that, we save it and we do the record module. In the record module number 1 will be record head assembly shipped. So this one is nothing but record of record. Basically we're going to say record head assembly shipped. Okay, that's record number 2, head assembly shipped. And but we don't need to have the number 2 here, we just take it record head assembly shipped. In the section here, in the statistics section, we're going to say time interval. We're going to do time interval, and then here we're going to do basically head arrival. So we're going to do, let me see what happened here. So we're going to do time interval. So we did record head assembly shipped. Sorry, let me just check back one. Record head assembly shipped, and we're going to add here time interval, and then attribute will be head arrival time. So it'll be height adjustable desk arrival time, head arrival time, and then the tally head shipped. This one will be tally, basically tally head height adjustable desk assembly shipped. All right, arrival time and then shipped. So this is going to be the statistical calculation for this, and then here it is basically talks about tally head assembly shipped, tally head assembly shipped, time interval, head arrival time. Very good. So this one is okay. Then we do the next one. This one is a record that will take the recording for the record reworked and salvaged. So this will be record reworked and salvaged. Reworked and salvaged. And here we're going to do again, we're going to do time interval. We're going to do head arrival time. So we're going to pick head arrival time, and then we're going to do tally record salvaged. So we're going to do tally, and then it'll be record reworked and salvaged. Reworked and salvaged. All right, so with that we have pretty much the second one covered, and then we hit OK, and then we go to the last one, which is the scrap. For this one, we're going to do record scrap. So we're going to do record scrap, and in the statistic description, we're going to do time interval, and we're going to do head arrival time, and here we're going to do tally scrap. Let me see if it is there here. No. So we're going to do tally scrap. Tally scrap. Okay. With that, we hit enter. Hit enter. All right. Now we're going to connect this all the modules. So let's connect this module. So if from here it'll go straight to the record, and from the record it'll go to the head assembly shipped, and from the inspection, if it is true, it will go to this record here, and then from there it will go to the salvaged and reworked and salvaged module, and the last one will come from, if it false means it's not 95%, that means the 10% will go here and it will scrap. Then the end of it is going to be scrap. So that's pretty much the conclusion of the process flow. We are not done yet, so we're going to now do a couple of things. We're going to go and do run, and under run we're going to go setup, and under setup we're going to do number of replication is 1. Today is Sunday, November 7, so we're going to check this, and then the wrap up time is hours, fine. Replication length we're going to put 10 hours. 24 hours is a day, and base unit of the time is minutes. And then we're going to see, is there anything we need to do here? No. So let me say apply, okay, and go to setup. Then we go to project parameter. In project parameter, we're going to write down the project title, which is pretty much like what we're going to do is, let's see what we have decided to put. We're going to put the Wawa, the name of the class assignment. So it's going to be 4, and then A, advanced manufacturing, 1, and it'll be underscore. My student ID will be 0411902237, 0411902237, CA2, 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 and then analyst name is my name. All right, and then portal description is initial arena simulation on height adjustable desk, height adjustable desk, HAD, column assembly process. All right, here we can do make sure that Q resources, we have check mark on entities and processes, and that's it. And we do apply, the OK. Now the last thing we need to do here is setup. Then replication is already done, project is done. Then we go to the report, and in report we have prompt me, company overview, and then we're going to do Simon report, which will be report summary. We're going to do apply, we're going to do OK. All right, now let us make sure the process, the initial basic process is done. What we're going to do now is check to make sure that there is no discrepancy in this process. Hope not. If there is, then I have to check for it. All right, so there is some module name to be unique. It is about the column. Okay, so let me quickly check and then I will correct it. Okay, we have pretty much finished the simulation right now, and I have checked all the modules pretty well. They are working well. As you can see that we have the decision-making processes after the assembly inspection and after rework, and then we have records before we go to the assembly shipped, reworked and salvaged and scrapped. And now what I'm going to do is, and also the entity box here, basically with each individual entity we have an identified color balls, that's complete. And the only thing that I'm going to do right now is, before we end this session, is put a box over the flow plan to and make an identification like a name to the flow. So first thing I'm going to do is I'm going to go to draw, and in draw I'm going to do a box, and I'm going to bring a box. Basically I'm going to bring a box over this, and so if I do that, that way I have a box, and I need to bring the cover back to send it to back. So there we go. So we have a box here. Let me open up the box a little bit, slightly more, so it can fit everyone inside. And let's see, here on the right side I'm going to put it a little bit out so the numbers are visible a little bit more. Okay, there we go. So we have that one with the color, and then I'm going to put another box here on top to put the title for this. Sorry, it didn't go. So I'm going to bring the box again. Let's see. Okay, so here is the other box, and in this box I'm going to put the title of the project. And here basically I'm going to put the text here that will say the initial arena simulation process, or arena simulation for height adjustable uh, desk, which is HAD, desk column assembly uh, uh, so arena simulation for height adjustable desk assembly process. All right, so that's that. Let me check the font. Maybe I'll make it a little bit bigger here, number 14, and then we do OK, and then I post it here. So this is the title of the array simulation that I have done. Initial arena simulation for height adjustable, which means that there is no improvement here. This is as is, just to show that we have made a simulation on the height adjustable desk process with 5 entities and pretty much 5 processes with 3 disposed models. And then what I'm going to do is I'm going to double check, make sure that first I will save it. Once saved, I go to the run, make sure that I put the names, numbers in the proper way. So let me do the home, and then we do run, then setup. And in the setup, I have already put the University of Wawasan name, and basically my name, and electrical height adjustable desk column assembly. And then 5 entities components are 5 entity slash components. I said moves through 5 processes. After that, all 5 components are jointly assembled to 1 unit at the final head assembly process. All right, and here I have got checked queues, entities, and processes. We already saw that in the earlier discussion, so that one is okay. And then I'm going to go to this setup and make sure that the replication, I've got 10 hours of replication. Basically, the replication length is 10 hours, 600 minutes. And the date will be basically, I'm going to adjust the date to today's date, which is 7th of November, as we have discussed earlier. And we just say apply and OK. As for the reports, we have already selected. I have selected Simon summary report, so which is okay. We just keep it like that. Everything looks good. Now we try this one more time to make sure that the model is saved, and check model. No errors warning found in this model. And now I'm going to do a run. To run, it'll show me if there is any. Okay, well, we already checked for any error. There is no error. And now we're going to do, finally, we'll run it. And sorry, it didn't run, so let's see what happened. So let's run it again. Here we go. Okay, it's running now with all the color balls for each of the entities. Okay, so looks like we have a report. We have about 90 units out, and if I press this, yes, I've got the report, final report, and this final report basically talks about the Ken Chakravarti arena simulation project is my for advanced manufacturing and my college ID, Wawasan ID, and CA2, my name, and then all the details of the report that I will save. Let me save it before we lose it. So save as, then I go to desktop and my Wawasan University 7th semester CA2 upload file, and then I'm going to say that this is the result. So this is the report. So I'm going to put it as report, and then save it. All right. So the simulation model for the height adjustable desk column assembly process, the phase 1 is complete. The next phase I will show you the animation, and then I will show you this third phase will be the improvement. Thank you very much.